OCR Maths and Stats, Differentiation Techniques for C3 and C4, Explicit and Implicit Functions and Differentiation. The following functions are all in the form y is equal to some function of x, where y is given explicitly in terms of x. These are explicit functions. So we have these derivatives of these explicit functions. Now x is equal to y cubed is also an explicit function. And differentiating, because it's x is equal to some function of y, it's dx by dy is equal to 3y squared. So these are all examples of explicit functions. An equation which can be written as y is equal to some function of x, or x is equal to some function of y, or something similar, is called an explicit function. This equation cannot be rearranged as y is equal to some function of x, or as x is equal to some function of y. This is not an explicit equation. This is an example of an implicit function. We can still differentiate implicit functions and then work out the gradient of a point on a curve, tangents, normals, stationary points, and so on, as long as we follow some basic rules. Let's have a go at differentiating this function with respect to x. So differentiating each term with respect to x. So the first one, differentiating x cubed with respect to x, and these two are both the same. These are both x. So differentiating is straightforward. We just get 3x squared plus, now differentiating this term is different to the first one. We have x here and we have y there, so these differ. So differentiate y cubed to give 3y squared, and this is the new part that you need to learn. You need to multiply this by dy by dx. I'm not going to go into the proof as to why you multiply by dy by dx. Equals, and then differentiating a constant gives 0. Dividing by 3 throughout, so x squared plus y squared times dy by dx is equal to 0. And then rearranging to get the derivative, dy by dx. Differentiating the product of two functions. So we're differentiating with respect to x, so using the product rule for differentiation. So function u is the x here, and function v is the y squared. So u equals x, v is equal to y squared. and differentiating both of these with respect to x. So du by dx, so that's x there, and this is x, so differentiating the x gives us 1, and dv by dx, and that's x, and that's y. These are different, so we get 2y, and then we multiply this one by dy by dx. Yeah, that's the basic rule for implicit differentiation, that if these are different, so that's an x, that's a y, you differentiate as you would normally do, and then you multiply by dy by dx. And then using the product rule for differentiation, if I just cross multiply these now, so v du by dx, so y squared times 1 gives y squared, plus u times dv by dx, so x times 2y dy by dx. So that will give 2x y times dy by dx. Differentiating this implicit function with respect to x, so differentiating the first term with respect to x, differentiating the second term with respect to x, and differentiating xy squared, we've already done that here, so we'll just use the result here, and differentiating y cubed with respect to x. So the first term gives us 4x. The second one, taking the result from here, y squared plus 2xy dy by dx. And differentiating y cubed with respect to x. And these are different, that's an x, that's a y, that's different, so differentiating y cubed giving 3y squared, and then we multiply that by dy by dx. Now the dy by dx terms, that's these two, they should be on one side of the equation, so I'm going to move this to the right hand side. So we've got 4x plus y squared is equal to 3y squared times dy by dx minus 2x y times dy by dx. And then we can do a bit of factorizing on this side. So we've got 3y squared minus 2xy times dy by dx, and that's all equal to 4x plus y squared, and then finally dy by dx is equal to 4x plus y squared over 3y squared minus 2xy. So to work out the gradient at any point on this curve, you just substitute the x and the y coordinate for a particular point into this derivative. Differentiating x ln y equals y squared with respect to x. So differentiate each term with respect to x. The right hand side is simple. These two are different. You've got x, we've got y, so differentiate the y squared to give 2y, and then you just multiply by dy by dx. The left hand side is the product of two functions, so we have to use the product rule for differentiation. So u equals x, v is equal to ln y, du by dx is 1, and dv by dx is equal to, and because that's x and that's y, So once you've differentiated to get 1 over y, we multiply that by dy by dx. And then cross-multiplying these two. So v du by dx, that's just ln y times 1, plus u times dv by dx. So that will give us x over y times dy by dx. So differentiating with respect to x ln y gives us ln y plus x over y times dy by dx. And then keeping the dy by dx terms together on one side of this equation, we have ln y is equal to 2y times dy by dx minus x over y times dy by dx. Factorizing, so the dy by dx, taking that out, gives us what, 2y minus x over y. And then writing these two terms as a single fraction. And then finally, dy by dx is equal to y ln y over 2y squared minus x.